Hello 8th class students, as we have completed sound lesson in our previous week, so this week you will get the videos of same exam fear but in a longer version. See, exam fear videos cover all the topics or all the activities which are there in the textbook, so do watch them carefully. Okay, so this chapter is very small, so it doesn't need much attention as per the weightage and as per the number of pages in any comparison. This chapter is very small, so go through these videos and make sure that you understand the topics well, and if you are not able to understand any concept or any topic, then you can raise the issue in the group, so that I'll be clearing your doubt personally through Zoom session or through personal meeting in our campuses. Okay.
Hello friends, this video on sound part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are Introduction, what produces sound, sound produced by humans, propagation of sound, human ear, oscillatory motion, amplitude, time period, frequency, audible and inaudible sounds, and noise pollution. So what do you think are we going to discuss when we say sound? I don't really think that I need to define what do we mean by sound. So let us quickly look at some of the examples which actually tells you that we hear a lot of sounds around us every day, every time. In fact, right now also, whatever I am speaking, you are able to hear it. Why? Because a sound is being produced. Think of a marriage party going out or a band going out. So they produce a lot of sound. I mean, they play a lot of instruments. You have the drums, you have the horns and the bells, and there's so many different types of instruments which are being played together, and that produces a different type of sound. You talk about any sort of music, you talk of the musical instruments like a flute or a guitar or a sitar or a tabla or a dholak. So there are so many variety of musical instruments, and all of them produce different types of sounds. You think of these living organisms like the birds. The chirping of the birds, different birds produce different type of sound. You compare the sound produced by a crow with the sound produced by a cuckoo. So their sounds are so very different. Think of a very simple thing, that is the bell. Whether it is present in your temple or it is present in your school premises. So the bell, you see, it again produces a different type of sound. Whatever we talk, like right now I am speaking and you are able to hear it because I am producing sound. When we talk, when we laugh, when we sing, so in all these situations, a lot of sound is produced which is heard by other person. Just look at these simple examples. You take a rubber band or anything which is elastic in nature. Just try to stretch it. Stretch it using both your hands and then leave it. What happens? It produces a sound. So in this lesson, basically we are going to talk about what produces sound. How is this sound produced? And how do we hear sounds? That sounds quite simple, because you might say that, okay, we have ear to hear sounds. Okay, now what we are going to discuss here is the structure inside the ear, how ear helps us to listen to different types of sounds, why are different sounds so different. Like the sound which is produced by a guitar is very much different from the sound which is produced by a human being while talking. Like the way I am talking right now, a specific type of sound is being produced, but the sound produced by a guitar, that is quite different. So how are these sounds, how is one sound different from another? So that is what we are going to discuss in detail in this lesson. So let us start with the importance of sound. I mean, why are we talking about sound? Why is it so important? So one basic necessity of sound is communication. Now, how do we talk to each other? How do we communicate our feelings to other person? Let us say you are hungry. Okay, so you need something to eat. So what do? You have to convey this information to your mom or whoever is there at your home that, okay, I'm hungry and I need something to eat. So how do you communicate that? You communicate by talking. You just tell your mom that, okay, mom, I'm hungry, and you give me something to eat. So when you speak, what is happening? Sounds are being produced, and because sound is produced, your mother is able to hear whatever you are speaking. So sound is very, very important for communication, not only for personal communication, like whether you talk about people talking over, not only face to face, but also over telephones. So these days you see distance doesn't really matter. So maybe one person is sitting out there in Bangalore, the other person is sitting somewhere in some other country, some other state. So they cannot hear their voice directly because they are too far from each other. But now you have your so many different modes of communication, so you can talk to each other over telephones. So there also sounds are being produced, and that is why you are able to communicate with each other. So communication is one very important thing where sound is useful. Next is music. Due to the presence of sound, we are able to enjoy music. In music also, you have many different types of music. You have happy music, you have sad music, and when you listen to music, it helps you to relax your body and mind. So the existence of music is due to the existence of sound. Signaling system. For example, you just think of the alarm clock, which wakes you up every morning. So this is something which is very beneficial for you, right? You don't really need to depend on any other person, maybe either your mother or your friend, to wake you up. You just have your clock, the alarm clock, which starts producing a very different type of sound when you are about to wake up. Let us suppose you want to wake up at 6 o'clock in the morning. So every day at 6 o'clock, your alarm clock, it produces a very different and very unique sound. And because of that sound, you wake up. So it is used in not only in alarm clocks, but also in different types of alarms like fire alarms, or also in schools. In schools also you have the bells, which tells you that, okay, the first period is over, then comes your second period, the third class, and so on. So everywhere you see, wherever you want to signal something, beginning or start of something, you want to wake up somebody, so that in those kind of signaling systems also sound plays a very important role. Locating objects. For example, let us suppose that you are not able to see, somebody has closed your eyes. Okay, now if you have to locate object based on their sound. Now if let us say your eyes are closed, you are not able to see where the different objects are. And now let us see that a train is coming from very far. Now as the train approaches you, what happens? The sound of the train increases. So by concentrating on the sound of the train, you can actually make a rough idea how far the train is from you. Because the closer the train comes, the sound becomes more stronger. And the further away the train goes, the sound becomes more faint. So by interpreting the sound which you are able to hear, you can also locate objects, that where that object is located. So that is another benefit of the presence of sound. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 2 is brought to you by examfear.com. No more fear from exam. So now the most important and the most basic question, what produces sound? How are these sounds produced? And that too, we have so many different varieties of sounds. Now, why are they different? That we will talk a little later. First, let us try to understand what produces the very basic sound. So whenever we talk about sound, all we can think of at the first go is the musical instruments, because different musical instruments, they produce very different sounds. So primarily sound is produced by vibration of objects. Sounds interesting, right? That sound is produced by vibration of objects. Now you might ask, what is vibration? So vibration is rapid to and fro motion of an object. Now what do we mean by to and fro motion? Let us look at this simple example which will help you to understand the meaning of vibration. Let us suppose you have a thread, and at the bottom of the thread you have tied a small stone. Now when you suspend it and you just leave it, you just push it a little bit on the side and then you just leave it or suspend it freely. So what is going to happen? So let us say you are holding it here. Now this will start moving in this fashion. It will go here, it will come back, it will go this side till here, again it will come back, it will go this side, it will come back, it will go this side. So this motion, this is known as to and fro motion. So once it is going on the right hand side, then next it is going on the left hand side. So this motion, when it happens very fast, so that motion is known as vibration. Now, you might be wondering that, okay, when we talk about sound, sound comes from so many different objects. It is not only the guitar which produces sound, even when we speak, we also produce sound. So that means there is some vibration involved somewhere. Yes, exactly. So there is some vibration happening inside our throat due to which we are able to produce sound. So we will talk about that a little later. First, let us look at the simpler examples. Let us take the example of the simple guitar. So in guitar, how is the sound produced? Have you ever seen somebody playing a guitar, or have you yourself tried playing a guitar? If not, try to get a guitar and just see how it looks. You will see that it has got strings like this. And when you pluck the string or when you move this string, the strings vibrates. And the vibration of this string in turn vibrates the entire instrument, because of which the sound is produced. So, in guitar it is relatively simple to understand that how vibration is involved in producing sound, because you can actually see the strings vibrating. But when you look at the other examples, for example, the bell which rings either in your temple or inside your school premises, so there also the vibration is quite noticeable, because you would have seen that the spherical ball inside, it keeps moving like this, and every time it strikes this side and this side, so there is this vibration involved which produces the sound. Let us look at some other examples, the most complex ones, maybe the way we speak. So when we speak, where is the vibration involved? So we will discuss that very soon. Think of this simple example. You stretch a rubber band and you leave it. What happens? So the band vibrates, and because of that vibration, sound is produced. Now when the vibration is very less, sound produced is also very less. When the vibration is very much prominent, so the sound produced is also more. So everywhere you see a sound is being produced, just consider that there has to be some vibration involved somewhere. Otherwise, without vibration, sound cannot be produced. So the cause of sound production is vibration. So now let us spend some time to understand in more detail about vibration. So as I said, vibration is a periodic to and fro motion. Now what do we mean by periodic? That means anything or any motion which takes place at periodic intervals of time. Now here I gave you the example of pendulum. So I'll be using the same example. Just observe the motion. How is the motion happening? It is moving from this extreme to this extreme, and it is periodically moving. If you start counting it like this, 1, 2, 3, 4 and so on. So it is happening at equal intervals of time. That means the time this ball takes to reach from the middle point to the extreme right is equal to the time taken from the middle point to the extreme left. So periodically it is moving. That is why it is a periodic motion. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 4 is brought to you by examfear.com. No more fear from exam. So now let us talk about the instruments, because when we are talking about sounds, not talking about the instruments will keep the discussion incomplete. So whenever we talk about sound, let's first talk about the pleasant sounds, sounds which we feel like hearing, which makes us feel good. And these kind of sounds come out of the various instruments. Now some of the instruments which you see on the screen are veena, tabla, harmonium. In case you are not aware of which are these instruments, let me just tell you. So this is how a veena looks like. This is veena, this is tabla, this is harmonium. This one is a pair of manjira. This is a ghatam. So this, you see, it almost looks like a earthen pot, but then it produces a very nice sound. This is dholak. This is ek tara. Why is it called ek tara? Tara means nothing but string. Ek is one. So this instrument just has one string. So you can see the one string prominently, and that is why it is called ek tara. So due to the vibration of this one string, it is going to produce a beautiful sound. Guitar, as you can see here. So these are some of the instruments which each of them produce a very unique sound, and as I mentioned, wherever sound is produced, there has to be some vibration. Now, the most interesting part comes here. Now, you might be surprised to know that, okay, when I talk about something like ek tara or guitar or veena, you can actually see the strings. So you can visualize it very easily that, okay, where vibration is happening. When you move the strings vibrate. So that is how sound is produced. But what about these other instruments like the tabla or the dholak or the harmonium? So where is the vibration happening in these instruments? So let us have a look at the vibrating parts of each of these instruments. So every instrument has a part which is capable of vibration and which vibrates, which in turn vibrates the entire instrument, and that produces the sound. So let us look at each of these instruments. Now, as I said, vibrations produce sound. Now, these vibrations in some cases are visible, whereas in some other cases the vibrations are not visible. So let us look at the simpler examples first. So we will take the example of the bell. So in the bell, you can very easily see the vibration. You can actually see this metal ball is vibrating along its mean position. Again, if you talk about instruments like guitar or ek tara or veena, so here also you can see the strings actually vibrating. So stretched string, they are the vibrating part of these instruments. So the strings are stretched, so they are like fixed at both the ends. So if you look at the strings of the guitar, it is fixed at this end and it is also fixed at this end. So both the ends it is fixed, and then when you move it, it is like a stretched string. It is already tight from both the ends and you are moving it from between. So what is happening? It is vibrating. So it is very simple. It is like, let us suppose you take a rubber band. So you just fix it on both the ends. Now, so this rubber band, now if you try to pull it or push it from here, you stretch it from here, what will happen? It will vibrate like this. It will start vibrating like this. It will move. So that is how these stretched strings also move. So here in these type of instruments, the vibrations are easily visible. But there are certain instruments where the vibrations are not visible. So let us look at some of those instruments like the tabla and dholak. So here we do not have any string. So what is vibrating in these cases? So in these cases, it is this membrane which is vibrating. So how do you play a tabla? So the person who is playing tabla, he beats on this membrane. So these membranes, they vibrate. So these are called the stretched membrane. Like how you have strings in case of guitar and veena, here in these type of instruments, you have a membrane. So in dholak also you have a stretched membrane. So when you beat it here, so that produces sound, because whenever you stuck it here, you apply some force here, this membrane start to vibrate, and when it vibrates, it in turn produces sound, and that is what we hear. So these type of instruments, they have a membrane which is capable of vibration when you beat it. Again, you have another type of instruments like a flute. Flute looks such a simple instrument, and it produces such a beautiful sound. Now what do you think is there in it? Because in a flute you neither have a string, nor do you have a membrane. So what do you have here? All you can see in a flute, if you look at the structure of a flute, all you can see are the holes which are present on its surface. And how do you play a flute? You just blow air through those holes, right? So with the help of your fingers, you keep closing and opening the holes. Whenever you don't want a hole to remain open, you just put your finger there and then you blow air through an open hole. So that is how a flute is played. If you want, you can have a look at somebody who is playing a flute. Okay, so what exactly vibrates in this case? Now, a flute is nothing but, it is like a hollow tube inside. You really don't have anything inside. It is just a cylindrical tube which is all hollow inside, and all you have outside are these holes. Now when I say there is nothing inside, that means what is there? Nothing but air. And when you blow through those holes, you are actually making air to flow through those holes. So air flows through the holes on the flute, and the stream of air, it creates a vibration of air at the hole. So it is basically the air which vibrates inside the hollow tube. And this vibration of air produces the sound which we hear. Right? Now, the type of sound or the pitch of the sound which comes out of a flute, that can be changed by opening and closing the holes on the body of the instrument with the help of your fingers. So if you ever closely observe somebody playing a flute, you will see that he is constantly blowing in air through the holes of the flute. So here you can see these are the holes on the body of the instrument. So that person will be constantly blowing in air through these holes, and at the same time his fingers will always be on one of these holes. He will keep on closing and opening these holes with the help of his fingers. So that is how a flute is being played. So here you saw that different instruments have different parts which are capable of vibration, but everywhere there is something or the other which vibrates, which in turn produces sound. Now, not only these instruments, there are a couple of other instruments where you do not have a lot of complexity. You just need to strike the instrument. For example, the ghatam. So I was just telling you, right, it is almost like a pitcher. So you just need to beat it. That's all you have to do. So once you strike on these type of instruments, what happens is, now, for example, I'll give you another example. You talk of tabla. So when you strike the membrane starts vibrating. Now, if you want, that is not very much visible. The vibration is not so prominent that you can see it from a distance. But if you want to feel the vibration, immediately after striking the tabla, just very gently place your finger on this membrane, and you will be able to feel that the membrane is vibrating. So that is how you can feel for yourself that how exactly these membranes vibrate. So these were some of the examples of the musical instruments. Now let us try to relate this concept of vibrations producing sound with some of the examples which we see around us. So some of such examples are the clock. Generally the wall clock which we have in our houses. So have you ever noticed the sound produced by the pendulum of the clock? So you will always have the ticking sound of the clock. And where does it come from? It comes from the vibration which is happening inside. So that is one example. The next one is the band party. So wherever you see there is some function happening, or you go to some orchestra or any sort of celebration, you see that people, they blow horn, right? So how do they blow horn? They just push in air, and the vibration of the air column produces the sound. A very similar concept like that of a flute. In flute also we were blowing in the air, and the vibration of the air inside the hollow tube was producing the sound. So in a very similar way here also, if you see, this person is blowing air inside the body of the instrument. So inside this instrument the air is vibrating, and that vibration produces sound. So not only these musical horns, even the horns in your vehicles, they also operate in a very similar way. So it is just that in this case you blow in air through your mouth, and in this case you have a structure like this. So you have a rubber bulb present at the bottom. So as you press this rubber bulb, it is like equivalent to pushing in air inside. So as this rubber bulb is squeezed, air is forced in. So air is forced in this space, and this causes vibration of the air, and when the air column vibrates, it produces sound. And this type of concept of horn is present, and that is why, that is how the horns of the vehicles operate. Now, different types of horns are available, like there are battery operated horns, there are small air horns also. So a variety of them are actually available. But the basic concept in all of them is that there is some or the other vibration which is taking place, because of which the sound is produced. So now with this, I hope that you are convinced that yes, vibration produces sound. So in many cases where even though we cannot see the vibration taking place, but yes, somewhere or the other, whether it is whether it is clearly visible or it is hidden, but vibration is taking place. So even we produce a lot. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 3 is brought to you by examfear.com. No more fear from exam. Now, many of you might get confused. You might be thinking that this type of periodic to and fro motion is called oscillatory motion. It is also called oscillation. But now we are saying that it is vibratory motion or vibration. So how is oscillation different from vibration? Well, they are not very much different from each other. Basically, they are the same thing. It is just that vibration happens very fast. So you can say a fast oscillation is often called as vibration. So there is no significant difference between oscillations and vibrations. Both are basically the same thing. Just that when frequency is small, we call it oscillation. Okay, now what is frequency? That might be the next question coming up in your mind. So we will talk about all these parameters a little later. So I'll park it for now. When we discuss about frequency, I'll come back to oscillation and vibration. Okay, so now let us take the example to understand this. Now, when we say that the frequency is small, that means it is not moving very fast. That means the way it is moving from one extreme to other extreme, that is relatively smaller. I mean, the speed is small. So that case, it is called oscillation. And the best example that you can think of is the pendulum of your clock. Do you think that it moves very fast? It doesn't move very fast. It moves considerably slower. So that is an example of oscillation. But when the same motion happens in a very fast way, that means it keeps moving. So oscillation is like this. So it will move like this. But in case of vibration, it will be like it is moving very fast, like this, like this, like this. So that is vibration. So example of vibration could be the guitar string. So when you look at the string of the guitar, you can actually see it vibrating, but it will be very fast. You can just, you cannot see how exactly it is going from end to end, but all you can feel is it is moving. It is in motion and it is in very fast motion. So whenever the frequency is very high, whenever the movement is very fast, there we use the term vibration there. And when the frequency is small, that means it is a slow motion, that is an oscillation. So that is the only difference between oscillation and vibration. Now when we talk about sound, we mostly talk about vibration because here we are talking about the fast motion. So here you look at this example. This is a very good example to tell you how fast vibration could be. You saw here how quickly it was moving to and fro. So that is an example of vibration. So now the question is oscillatory motion periodic? Of course it is, because as I said, oscillatory and vibratory, they are the same thing. They are periodic motion. So every oscillatory motion is periodic. That means for every oscillatory motion, it will happen in equal intervals of time. But that doesn't mean that every periodic motion need to be oscillatory. Now, What do we mean by periodic motion? A motion where equal distances are covered in equal intervals of time. Now let me give you an example of periodic motion which is not oscillatory. Let us suppose. Now let me give you an example where the motion is periodic but it is not oscillatory. So one such example is the rotation of the earth around the sun. So if you look at this motion, what kind of motion is it? Is it periodic? Yes, of course, because the time taken to complete one rotation is always fixed. So every equal interval of time, it is covering the same distance. So obviously this is a periodic motion. But do you think it is oscillatory motion? So anywhere do you see a to and fro motion? It is not a to and fro motion. So this motion is periodic, but it is not oscillatory. So not every periodic motion has to be oscillatory, but yes, all oscillatory motion, they are periodic, because every oscillatory motion is going to be a to and fro motion, and it is also going to be periodic. It will happen periodically. So every oscillatory motion is periodic in nature. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again. Hello friends, this video on sound part 7 is brought to you by examfear.com. No more fear from exam. Sound can never travel through vacuum, and vacuum means complete empty. It has nothing. Nothing means absolutely nothing. Many of you might be getting to know this term vacuum for the first time. So let us try to understand what is vacuum. It is a space which is completely devoid of matter. Please remember, it is completely devoid of matter. Matter means anything that occupies space is matter. Solid, liquid, gas, everything falls under matter. Now let me give you a very simple example to explain what do we mean by vacuum. Let us suppose you have a bottle, and this bottle is filled with water, right? So will you say that the bottle is empty? No, because the bottle is already filled with water. So right now, what do you have inside the bottle? You have liquid inside the bottle. Now what do? You take out the water which is present inside the bottle. So you have taken it out. So now, will you say that the bottle is empty? Yes, many of us would say that yes, the bottle is empty because there is no water inside the bottle. But if I ask you, is there anything present, or is there matter present inside the bottle? Yes, of course, because air is present inside the bottle. The moment air is present everywhere around us, right? So the moment you take out or you pour out the liquid from the bottle, so even before you can put the cap on the bottle, air enters inside. So air is sitting inside the bottle. So now also the bottle has matter. Now, there are techniques by which you can take out even the air from the bottle. And then what do you say? The bottle is completely devoid of matter, because now it doesn't contain any liquid, any gas, nothing is there. And then we say that a vacuum has been created inside the bottle. Right? So that is vacuum. So vacuum means absolutely nothing, no matter at all. Now, you might be thinking that it might sound to be little imaginary for you, that something like vacuum also exists, or how do we create vacuum? Now, as you go to your senior classes, you will learn about the various methods by which you can create partial vacuum, or you can create vacuum. So I will not get into those details right now, but yes, it is not an imaginary concept. Yes, it is possible to create vacuum. You can actually create emptiness, complete emptiness inside an object. So I will give you some of the examples which you see around yourself where you can feel vacuum to some extent. So one such example is a magic, which is often shown to kids, but it is not actually a magic, but a simple scientific phenomenon. All you need to do is take a glass, fill it with water up to the top. So completely fill it with water. Now you place a paper card over it. Okay, sounds simple? Now as soon as you place the paper card over it, you quickly turn it upside down like how it is done in this picture. So now this glass is completely filled with water and this is the paper card. Now as soon as you turn it upside down, what do you expect to happen? Normally what we expect is that the paper card should fall down and the water inside the glass should also fall down. That is what we expect. But you will see a magic. What happens is, even when you turn it upside down, the paper card sticks to the glass. So it is like a magic. The glass is turned upside down, but the entire water is there inside the glass and the paper card is also sticking to it. So many magicians show this as a magic, but there is actually a very simple science behind it. What happens is, a low pressure area or partial vacuum is created, and due to the creation of this partial vacuum, where is this partial vacuum created? Now, normally why do we expect that the paper card will fall? Because the water which is present inside, this weight of the water will push the paper card downwards, and that is why the paper card will fall and the water will also fall. That is our expectation. But what happens is, just between these two layers, like you have water here and this is the paper card, just between these two, a very thin layer of vacuum is created. Vacuum means where there is nothing, no air, no water, nothing. So this vacuum acts as a separation between the water and the paper card. So the water is not able to push the paper card, and that is why the paper card is not falling down. So that is the simple logic. So here you see the role of vacuum. So here partial vacuum is created. Another example where you can see partial vacuum is the suction caps. Have you ever seen these kind of caps? So I'm sure you would have seen it. I mean, you often use it for hanging stuffs. So they also have these kind of suction caps. And what happens to them? When you stick them to a smooth surface, they get stuck very tight, and then it becomes very difficult to bring them out. So why are these caps being able to stick to a smooth surface so tightly? That is also due to the creation of vacuum. So the space inside this inside space, it has vacuum. So there is no air inside. So it becomes airtight. So you would have heard the term airtight quite often. These days, there are so many containers which they say that they are airtight containers. So if you keep food materials inside that, so air will not be able to enter, and that's how they will not get spoiled and all. So basically vacuum, I hope you would have understood by now what is vacuum. Okay, so now what we were talking about was the propagation of sound. So now if sound wants to travel from one place to another, it needs a medium, and it cannot travel in vacuum. So these were the two important conclusions. Now, one very popular experiment, which is known as the bell jar experiment. So this experiment showed that sound cannot travel in vacuum. Now, when I say that sound cannot travel in vacuum, what I mean is, so if there is a sound being produced from some source, other people will not be able to hear it if it is all vacuum, because sound will not be able to get transmitted from the source to the listeners. So here in this apparatus, so here you can see this is a bell jar. So this is the jar, as you can see, and this jar is connected to a vacuum pump. So the purpose of this pump is to create vacuum inside. How will it create vacuum inside? By taking out all the air from the bell jar. So here inside you have vacuum. That means it is devoid of matter. Nothing is there inside. And inside this you have this electronic bell. And the switch of this electronic bell is somewhere here, as you can see here. So now what do you normally expect? If you switch it on, the bell should ring, right? And in normal situation, what happens? When your doorbell rings, you are able to hear the sound of the bell. Why? Because sound can travel through air, and air is present around you in your house. But in this case, when you switch it on, the bell rings, but you are not able to hear it because it is all vacuum inside. So the sound is not able to travel from, this is the source of the sound. So the sound is not able to travel from here. And that is why nobody is able to hear the sound of the bell. So this is a very popular experiment which proved that sound cannot travel through vacuum. And therefore sound needs a medium to propagate. And this medium could be a solid, it could be a liquid, or it could be a gas. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.